Good morning to everyone. I'm Dr. Sumi MS. The name of the course is Electromagnetic Fields, and today's lecture topic is Coulomb's law and Gauss law from Unit 2 Electrostatics. On completion, the students will be able to understand Coulomb's law as well as Gauss law. Introduction. Two fundamental laws that are governing the electrostatic fields are Coulomb's law and Gauss law. Both these laws have experimental basis. Coulomb's law is applicable in finding electric field due to any charge distribution, and Gauss law is easier to use when the distribution is symmetrical. Coulomb's law. Coulomb's law states that the force between 2 point charges Q1 and Q2 is directly proportional to the product of the charges and or inversely proportional to the square of the distance between them. A point charge is a charge that occupies a region of space which is negligibly small compared to the distance between the point charge and any other object. Point charge is a hypothetical charge located at a single point in space. It is an idealized model of a particle having an electric charge. Mathematically, we can give the Coulomb's law as F is equal to K into Q1 Q2 by R square, where K is the proportionality constant given as 1 by 4 pi epsilon naught, and in SI units Q1 and Q2 are expressed in coulombs and R is in meters. Here the force F is in Newton and epsilon naught is the permittivity of free space. Here we are assuming the charges are in free space. If the charges are in any other dielectric medium, then we have to consider the permittivity as epsilon is equal to epsilon naught epsilon r, where epsilon r is the relative permittivity or the dielectric constant of the medium. Hence, F is given as 1 by 4 pi epsilon naught Q1 Q2 divided by R square. Let the position vector of the point charges Q1 and Q2 are given by R1 vector and R2 vector, and let F12 vector represent the force on Q1 due to the charge Q2, and this charges are separated by distance of R, which is equivalent to R1 vector minus R2 vector, which is equal to R2 vector minus R1 vector, and we can define the unit vectors as A12 cap is equal to R2 vector minus R1 vector divided by R, and A21 vector cap is equal to R1 vector minus R2 vector by R. Therefore, the force on charge Q1 due to charge Q2 can be calculated as F12 vector is equal to Q1 Q2 divided by 4 pi epsilon naught R square into A12 cap, which is equal to Q1 Q2 divided by 4 pi epsilon naught R square R2 vector minus R1 vector divided by modulus of R2 vector minus R1 vector raised to 3. Similarly, the force on Q2 due to the charge Q1 can be given as vector F force vector F vector 21 can be written as minus of F vector 12. When we have a number of point charges to determine the force on a particular charge due to all other charges, we can apply the principle of superposition. If we have n number of charges Q1, Q2 up to Qn located respectively at the points represented by the position vectors R1 cap, R1 vector, R2 vector up to Rn vector, then the force experienced by the charge located at R vector is given as F is equal to Q by 4 pi epsilon naught summation I equal to 1 to n Qi R my R vector minus Ri vector divided by modulus of R vector minus Ri vector raised to 3. Gauss law. Gauss law is one of the fundamental laws of electromagnetism, and it states that the total electric flux through a closed surface is equal to the total charge enclosed by the surface. Let us consider a point charge Q located in an isotropic homogeneous medium of dielectric constant. The flux density at a distance r on a surface enclosing the charge is given by d cap is equal to epsilon into E cap, which is equal to Q by 4 pi R square A vector. If we consider an elementary area ds, then the amount of flux passing through the elementary area is given by d cap into ds, which is equal to q by 4 pi r square ds cos theta. Here ds cos theta by r square is equal to d omega is the elementary solid angle subtended by the area ds at the location of q. Therefore, we shall write the flux as q by 4 pi into d omega. For a closed surface enclosing the charge over a surface integral S, we shall write the flux density as closed integral over S d omega, which is equivalent into q by 4 pi, which is equivalent to q. Quiz questions on Coulomb's law and Gauss law. Explain Coulomb's law in electrostatics. Give a note on Gauss law. Thank you.